Hello class, this is going to be our flipped classroom on energy. As usual, pause the video when you feel like you need to copy down the notes. So this is going to be a very short video. We're just going to talk about the different types of energy, and even though there are many classifications of energy, there's chemical energy, thermal energy, mechanical energy, we're going to break all energy into two categories. We're going to call them potential and kinetic. So something is either potential energy, which means it's energy that is stored, or it is kinetic energy, which is energy of motion, which relates directly to thermal energy, in other words, heat. So what exactly is heat? Well, heat is the energy transferred between two bodies. So for example, if I take an ice cube and I put my hand on it, the heat from my hand will enter the ice cube. Heat will transfer from my warm hand to the cold ice. How is this different from temperature? Because a lot of people get these two words confused. Temperature is a measure of the warmth or coldness of an object with reference to a standard value. So what this means is temperature can be measured in, say, degrees, where heat is not measured in degrees. Heat is measured in other units, which we'll get to in a bit. But to keep it really simple, let's just say this. In short, temperature is a measure of only average kinetic energy of particles, where heat is a measure of both potential and kinetic energy combined. Now, how is this different? Well, this is how it's different. You can actually heat up an object without it changing temperature. I know that doesn't sound rational, but picture this. Let's say you take an ice cube out of the freezer and it's at 0 degrees Celsius and you let it sit on your table. Eventually that ice will melt. But if you put a thermometer on the ice cube as it's melting, the temperature remains 0 degrees. It doesn't actually get 1 degree warmer until it becomes liquid water. Does that mean that heat's not going into the ice? Of course not. The ice is getting warmer, but it's not raising in temperature. So, let me put it to you this way. We measure temperature in units of degrees Fahrenheit, degrees Celsius, or Kelvin. These are the units we could use. So we could say that the object got 5 degrees warmer. Heat is measured in calories or joules. And yes, sometimes when you heat up an object, not only does the temperature go up, but the heat increases. Sometimes, as in the ice cube example, you can put heat into the ice, but the temperature remains the same. Now let's learn these two words, exothermic and endothermic. Exothermic simply means heat released, and endothermic means heat absorbed. So again, if I'm putting my hand on an object and my hand is warm, the heat from my hand will be released into the object, or you can look at it as the object is absorbing the heat from my hand. And lastly, because this is always a question on so many different variations of testing, the higher the temperature an object is, the higher the average kinetic energy it has. So when a question is often asked, which of the following has the highest average kinetic energy, it's just a trick way of saying, which one of these is at the highest temperature? That is it. So if a choice between two objects, one's at 35 Celsius and one's at 45 Celsius, the one at 45 Celsius has a higher average kinetic energy. Likewise, if I have water in 3 different phases, solid, liquid, or gas, I don't need to know what the temperature is. I would assume that the gas must be at the highest temperature. Therefore, the gas would have the highest average kinetic energy, and the solid would have the lowest average kinetic energy. Now, this does not necessarily work for things that are not the same matter. For example, if I compare the air in this room to the desk that I'm currently writing on, both the air and the desk, even though the air is a gas and the desk is a solid, they both have the same average kinetic energy. Now, how do I know that? Because they're at the same temperature. And that is our lesson on energy.